So in this video, what we're going to do is I'm going to give you a function, a quadratic function, and we are going to find all of these different characteristics about the function, including changing forms, the vertex, domain, range, intervals of increase and decrease, all that fun stuff. Okay, so we are not sketching. We are going to use this information to find and plot the graph. All right? So I'm going to start out with going from standard form to vertex form, just like we did in the previous examples. So my equation here is x squared plus 4x plus 3. I'm going to set it equal to 0. My a value is already 1, so that's a good thing. I don't have that extra step on it as dividing it out. I'm going to move c over by subtracting c. And remember, you're going to leave some room for your new c value. Okay, your new c value is going to be using that formula, b divided by 2 squared. Okay, so b divided by 2 squared. Your b value in this equation here is 4. So I'm going to take 4, divide it by 2, which is 2, and then square it, which is also 4. So it's like I'm going to add 4 to both sides of this equation. The left-hand side is now called a perfect square trinomial. When I factor it, I am going to have the same factor twice, okay? So the shortcut to factoring is just take your b value that I've highlighted and divide it by 2. So that is x plus 2. And then combine like terms on the right, which would give me 1. And the last step is just move that 1 over. Okay, so my function, I'm going to go to the top here, is f of x equals x plus 2 squared minus 1, because it has to change signs when I move that 1 to the left side. By putting this in vertex form, I can find the vertex, which is -2, -1. Remember, the vertex is made up of h and k. H lies to you. So even though it looks like a +2, it's really a -2. That means that I'm going to go to the left 2. Okay, so let's go ahead and plot that vertex. -2, -1 should be right here. Axis of symmetry is going to be a vertical line that goes through the vertex. So since I already have the vertex, I can go ahead and find that axis of symmetry. So a vertical line goes up and down, so it has to go through that vertex point. Now when I write out what my axis of symmetry is, it's going to be x equals your h value, because that is the number it's going through, which is -2. Okay. Zeros are also where they cross the x-axis, also known as x-intercepts. So what I'm going to do is I'm going to find the zeros by hand, just because we know how to do that. We're going to build these connections with everything we've done so far this semester. So when I find the zeros, you can do it one or two ways. You can use the vertex form to set equal to 0 and solve for x, because we know how to do that by square root method. Or if you like, you can use the standard form that was given to us and factor. So I'm going to use that. I'm going to take that x squared plus 4x plus 3. I'm going to set it equal to 0. And I'm going to factor using the big X method. Okay, so if you remember this, a times c goes at the top, b goes at the bottom. So I want two numbers that multiply to give me 3, but add to give me 4. So that will include 3 and 1. Put your x's in front. And I should not have to do slide and divide here because my a value is already 1. So, sorry, I apologize for my dog. So now that I have each of these factors, I'm going to set them equal to 0 and solve for x. So on my first equation, this should give me x equals -3 My second one should give me -1. So what that means in terms of my zeros, if I want points, this will have a 0 of -3, 0. So I'm going to go ahead and plot that, which is right here. And -1, 0. Okay. Because I'm looking at where these are crossing the x-axis, my y-coordinate should always be 0. Right. The next thing I want to find is including the y-intercept. So the y-intercept is where this graph is going to cross the y-axis. The easiest way to find the y-intercept is to look at your standard form. The y-intercept is when you let x be 0. Now, if I let x be 0, this will give me 0, this will give me 0, and I'm left with just the constant. So my y-intercept is also my c value in my standard form. And it's a point. So my x is 0, my y is 3. So 0, 3. Okay, so that's it in terms of points. I have enough to continue graphing, but I do want to draw your attention to one thing here. The axis of symmetry is a line of symmetry. So if I have a point to the right, which is right here, that y-intercept, and I can count the distance to my axis of symmetry, and then go the same distance to the other side, I can get another point. So, for example, I have the point 0, 3. That is 2 units away from my axis of symmetry. If I go 2 more units, I will get my point here. Because everything on the right-hand side should be reflected over that axis of symmetry. Okay, so I can get more points this way. That's also a way for you to check your x-intercepts to make sure they're correct. They should be the same distance from the axis of symmetry. Okay, my domain here is my x values, and we talked about how it should always be all real numbers for quadratics. That means I can have any value for x in my function. For my range, I look bottom to top. The bottom of my graph starts at that -1 value. And at the top, I have those arrows, so that means infinity. Looking at the graph from left to right, I see that I decrease first. And remember, I only use the x values. Okay, so my interval of decrease is going to start at the beginning of my domain, but end when x is -2 at that vertex. And then after that vertex, it's going to pick back up and then go to infinity. Okay, so we have successfully graphed this function without using our calculator. So what I want you to do is I want you to try the next problem, very similar, and I will post the answer to that to make sure you can get it. And then watch the next video for us to graph these using our calculator in word problem format.